So the potential divider comes up in the leaving cert exam. Okay, it might come up in section A, and more than likely will come up in your option on electronics. Now, yes, the same as the junior cert, whereby you can use resistance to work it out. Ohm's law to work it out. By finding the current and then working out the resistance. Or you could use this formula either, where V out is equal to R2 divided by R1 plus R2 multiplied by voltage in. Okay, we'll give you your answer too. It's just about finding the potential voltage in between two resistors. Okay, and that normally leads on to another component. So let's have a look at leaving cert. Okay, before we move on, I would recap on that. So at leaving cert, the potential divider on its own would come up in section A. Okay, there are different ways to work it out, like I just shown you. You could use Ohm's law, you could use a formula, or you could just rationalize it. Okay, so they're saying here that a circuit requires a 5-volt supply. Okay, so it says 6 volts here, but they mean at this point A. Find the value R2 in order to deliver that 5-volt supply at A. So A here is going to go on to a transistor or a 555 timer or potentially op amp or something like that. Okay. So rationalizing it, okay, let's think logically. We got 6 volts in, we got voltage dropped here, and then we have 5 volts. Then we got more voltage dropped, and then we have 0 volts. So we got 1 volt dropped across R1, and we got 5 volts dropped across R2 because we have 0 here. So if 120 ohms drops 1 volt, well then a resistor 5 times bigger than this will drop 5 volts. So our resistor at R2 is 120 times 5, which is 600 ohms. Let's have a look at this solution with a marking scheme. So you can use a formula, or alternatively, you can explain it the way I did and just write in your answer, 600 ohms. Okay, so always put in a little explanation as to which way you're doing it, just to back yourself up and get those marks. Now, at the bigger question, all right, so for example, 2018, electronics and control, an op amp circuit, we got 2 potential dividers. Okay, so what is the potential voltage at this point here is what they're asking. Okay, so so in part 2b, calculate the voltage at B. So what is the voltage at B? We got a resistor here and a resistor here. We got V in here, and what's V out here? Okay, so I would use the formula for this. Okay, so this is R1 here, R2 here. So V out, what is the voltage out? So R2, 30 ohms divided by R1 plus R2, which is 50 ohms, multiplied by V in, which is 6 volts, will give us 3.6 volts. So at X there, we have 3.6 volts in our circuit. Okay, now let's have a look at the rest of the question. Okay, so it says, using your answer from above, 3.6 volts, calculate the resistance of the LDR, there's our LDR, at point A. At point A is the same as the voltage at point B. So when the calculate the resistance of the LDR, when our voltage at point A is the same as our voltage at point B, 3.6 volts. So we have voltage and we have resistance. Oh, sorry, we're looking for resistance. Okay, and we have voltage. Okay, so let's see what we can do. So I would look at the full potential divider here, and I would start thinking about Ohm's law. All right, I'm looking for R. All right, I can find V, so that means I can find the current. Okay, at point A. All right. So yeah. So let's see now. We have 3.6 volts here at point A. We know that 3.6 volts. And we also know that it drops across here. So we got a voltage drop across this resistor of 0 volts. So we got 3.6 volts here. And we know the resistance, which is 15 kilo ohms or 1500 ohms. So I across the resistor, the current across this resistor is equal to V, which is V over I. Oh, sorry, I is equal to V over R. 3.6 divided by 1500 gives us a current of 0.024. Okay, use green there. 0.024 of a current at point A. Okay, so we know we can work out the voltage at A, and we have the current at A. So now all we have to do is work out the resistance across here. Now we need to think about this a bit more now. All right, so we got 6 volts coming in here, 6 volts, and we got 3.6 volts here. So we're after dropping voltage across our LDR. All right, how many volts did we drop? Well, it's 6 minus 3.6, which will give us 2.4. So we have 2.4 volts dropped across our LDR here. Okay, and we know our current across here now because we have the current at this point. So we can say that R is what we're looking for. R is equal to V over I. R is equal to the voltage dropped across the LDR, 2.4, divided by the current at that point, which is 0.00024, which will give us an answer of 10,000 ohms or 10 kilo ohm resistor. Okay, so basic potential divider, Ohm's law, think logically, and you'll be able to work these out. Let's have a look at the circuit of that. Okay, so so we got 3.6. Sorry, we'll run it there now. We got 3.6 volts in there, 3.6 volts in there, and yeah, when our light level, when we got light shining on it, we have a value of a 10K or 9.6K LDR at that point. Okay, and we can watch as we change our LDR. You know, we're changing resistance. Our resistance has changed here now, so we should have, yeah, there we go. We got 676 millivolts, just over half a volt now. Okay, because we've changed the parameters of our potential divider, and we got a different voltage in here now. Okay. Oh, let's also have a look at the answer for that. So the marking scheme said 6 volts minus 3.6 volts equals 2.4. And then they said the resistance of that resistor divided by 3.6 multiplied by 2.4 equals 10. And I don't understand that right now, but I do understand Ohm's law and rationaling, and then working out your answer. Okay.